Right, good morning, boys and girls. Here we go. This is activity 3.1, 3.2. What happens if we heat and cool air? What happens if we heat the air? What happens if we cool the air? And again, I showed you this in Zoom classroom earlier in the week. And, the assignment is now posted in Google Classroom. And I'll upload this video recording to it a little later in the morning, and you can refer to this video if you need to help you answer the questions when you're asked, like, what happens if I heat a gas, what happens if I cool a gas. And let's do the soap bubble one first. And this one, I have some soapy water, and I just got the soapy water on the top of the bottle, and I have some warm water here, right? And as you can see, you see the soap on the top? Yeah, there's a little soap bubble. It kind of like sank. It moved. The soap bubble was at the very top here. Let's see. Yeah, the soap bubble was at the very top, but it kind of sank down, and I can see the soap bubble like right there. But it doesn't really matter because this is very unambiguous. You'll see the soap bubble very clearly as it goes in the hot water. You see the soap bubble coming up. You see it inflating. See the soap bubble has formed like a bubble now, right? And then it popped. So again, we can, one more time. And here we go. Right, there goes the bubble is like huge, and it's just from the air being hot in there. When I take it out of the water, you see it's cooling down now and getting smaller and smaller and smaller. If I put it in the cold water, it goes all the way back down into the bottle the way it was before. So heating the water expands, you get to see the bubble. When we cool the water, it goes back down. Same thing. And you can keep doing it all day, right? I don't know why you want to, but you could. Right, there it goes again, popping up. Oh, wait, take it out. It's back in the cold water. Now it's getting smaller and smaller in the hot water. And here it comes, see it popping back up. Right. I wonder if it actually would pop. I don't know. Oh yeah, it did pop. Okay, so that's doing that. And then of course heating. If we heat the water, I have a little warm water here. I got some. If I heat this water and get it pretty hot, I've done this several times. So if I heat it for like 15 seconds, that usually works pretty well. Anything more than that, it starts to get too hot and the bottle starts to melt or whatever. Yeah, you can hear it popping. That's enough. That's only 8 or 10 seconds. Oh, I got the top on. How silly. Leave the top off, boys and girls. Don't put the top on. Okay, here it goes. I was wondering why I was making that crackling noise. All right, 5, 4, 3, 2. It's crackling again. That's good and hot. Yeah, I can see the water boiling. Look at that. See the water boiling in there already? See if and the steam is driving the regular atmosphere air out. And now, see the bottle? Okay, watch what happens when we put it in the cold water. There's ice in there. That water is cold. Ready? Hear it? Oh, listen to that. You can hear it cracking. And it's crushed down. You can see it really good on the side view. Yeah, and it's crushed down. Oh, it's still popping. The poor thing. So you get the idea, right? You heat the stuff up, the gas expands. You cool it, it contracts or shrinks, right? And it's the same thing with air out in the world. When the sun warms up air, it starts to get hotter. The air gets hotter. It expands. It absorbs moisture, and we get a warm, moist air mass. If it's cold, the mass will shrink. Any water that's in there will kind of like just condense and precipitate out. When the cold air and warm air hit each other at that boundary, the warm air cools rapidly, and we get rain. Really quite simple. All right, talk to you later.